But how many startups are there that use blockchain or DLP for managing health data or medical records? Do they even exist? How are they doing? Make yourselves comfortable, because we're about to embark on quite a journey. Hello from Fabio Fiorentini. Welcome to a new episode of Blockchain for Healthcare. Did you know that in the Italian National Health Service, dozens of different management software systems are used, often unable to communicate with each other? This system, known as digital fragmentation, often leads to duplication, delays, and additional costs, hindering the quality of care. We hope that with the arrival of the Electronic Health Record 2.0, many of these issues will be resolved. However, as we saw in the previous episode, blockchain technology can also be a solution, as documented by industry literature, and above all, by a number of startups that have ventured into the market. Starting today, I will begin talking to you about those very startups. Before continuing, I want to give you some figures from two reports, both by the company Mordor Intelligence. The first concerns the blockchain market applied to the healthcare sector, while the second concerns the EHR market, that is, electronic health records, which we discussed in the previous video, meaning medical records. Both periods refer to an estimate covering the years from 2025 to 2030. So, as for the blockchain market applied to healthcare, it would go from 5.5 billion in 2025 to 45.37 billion in 2030, with a compound annual growth rate of 52.48%. Meanwhile, the medical records market would go from 22.15 billion in 2025 to 29.86 billion in 2030, with a compound annual growth rate of 6.15%. What do these numbers mean? It means it's entirely reasonable to confidently assume that the burgeoning blockchain market within the healthcare sector will, between now and the year 2030, progressively take a significant and substantial share of the medical records market. The primary reason I'm explaining this to you is simply because there might be a lingering impression that I'm discussing something truly out of this world, something perhaps too futuristic or abstract. Because in fact in Italy this important topic is not discussed at all whatsoever, and also because frankly it's truly bitter to say there is essentially nothing here to speak of. Whereas outside of Italy, as someone important once said, and yet it moves, and those who will play the leading role will definitely be North America, followed by Asia. A little while ago I said that starting today I will begin telling you about this startup. Obviously, it's implied that everything won't be covered all at once. With today's video, in fact, we're starting a journey, because while I was preparing this video, I realized there's a lot of material. Not only that, in my opinion, some startups deserve a dedicated deep dive, meaning a dedicated video. For now, the best thing to do is to divide these startups into 4 categories. The first category is healthcare data management, where we find Medical Chain, Avenir Health, GuardTime, and then MedRec, Factum, and GEM. The second category is decentralized care coordination, which includes Solve.care, Patientry, and Stratum. The third category is data ownership and privacy, where we have My Health, My Data, MediBlock, HealthWith, Elysium, Equidium Health, and Brown.tech. Finally, the fourth and last significant category is that of innovative healthcare marketplaces and decentralized insurance platforms, with notable examples including Pocket, Doc, and MediShares, all offering unique solutions. In the healthcare data management category, I think it's important to mention MedRec. This is a project from the MIT Media Lab and dates back to 2016, not that long ago, but still quite a few years back, and it was presented in a paper at the Second International Conference on Open and Big Data. And this paper serves as a sort of white paper. What is a white paper? It's a technical document that essentially serves to present the project to potential investors, funders. And in fact, the white paper contains the project's objective. That is, what problem this project aims to solve and how, with which technologies, and how these technologies are applied. In other words, the entire architecture of the project itself. And in cases where there is also a tokenomics, like in this one, how it works. MedRec is a project that aims to solve the classic problems of the healthcare sector, namely the fragmentation of data, the difficulty of access to it by doctors and patients, especially patients, and the usual challenge of achieving data interoperability. First of all, let's clarify that MedRec is based on blockchain technology, and in this case, the blockchain used is public and permissionless, because we are talking about Ethereum and the data itself is not stored on the blockchain. Instead, only the metadata is recorded there, that is, information about access and where the data is located. Therefore, medical records remain in the local databases of the providers, and the blockchain in fact only tracks the metadata and permissions. In this way, MedRec operates without requiring a complete replacement of existing infrastructures. And this is no trivial matter. Moreover, MedRec uses a modular architecture that allows it to integrate with healthcare databases at providers, for example those using SQL. As for smart contracts, what do smart contracts actually do? They effectively manage access and consent, and therefore they are the primary ones that meticulously regulate who can securely view, share, or modify the sensitive data. For example, when a patient willingly grants secure access to their sensitive health data to a trusted doctor, at that very precise moment, as soon as this crucial access is officially granted, the smart contract automatically and instantly authorizes this access and promptly notifies all relevant parties of any subsequent changes or updates. Another interesting aspect is the incentives. MedRec introduces an incentive system for network participants, who can be doctors, healthcare facilities, or even researchers. And those who maintain the network by validating transactions can be rewarded with access to anonymized data that is useful, for example, for research purposes. One last thing, which is by no means trivial, precisely because it is crucial for interoperability, is that MedRec was designed with the goal of supporting open standards for the exchange of healthcare data. So that well-known FHIR standard we talked about in the previous video. Now let's take a look at the most important components of MedRec, starting with smart contracts. We have the register contract, which is the one that associates each participant's identity with their address and film. Then there's the patient-provider relationship contract, or PPR, which regulates access permissions between the patient and the provider. And finally, the summary contract, which is a sort of aggregated registry that allows patients to have a centralized view of their medical reports. Let's consider the register contract, which is the one that associates a user's identity with their Ethereum address. So, the most relevant components are the unique identifiers, which could be a name, or a document number, or any other element capable of uniquely representing that user. And then the Ethereum address, which is the output of the mapping. In fact, it's what allows other smart contracts to interact with that specific patient, with that specific user. And then the registration policy, meaning the rules that establish who can register, modify, or revoke an identity in the register, for example, on the certified entity. So in practice, what do we have? A patient registers using their unique identifier and is mapped to their Ethereum address. A doctor who wants to access this user's data consults the registered contract. In fact, this allows them to verify the patient's identity and find their Ethereum address. And at that point, they then retrieve and interact with the summary contract. Now let's move on to the PPR, contract or patient-provider relationship. Contract, as mentioned earlier, this is what manages access permissions to medical data between a patient and a healthcare provider. The PPR contract has several main functions, including managing the relationship between patient and provider, because it contains information about the records managed by providers on behalf of the patient, as well as access permissions. Then there are the pointers and the data, because, as mentioned, nothing is stored on the blockchain. So the PPR contract contains pointers, which are usually queries or hashes, indicating where the records are located, that is, in the local databases of the providers. Then we have the access permissions, because it's precisely the PPR contract that allows the patient to grant or revoke access to a doctor, or possibly to a third party who could be a researcher. So we have automatic notifications. When a new record is entered by a provider or an existing record is modified, a notification is automatically sent to inform the patient. And all of this is thanks to the PPR contract. Finally, traceability and auditability, because when permissions are modified or data is added, everything is actually recorded immutably on the blockchain, thus ensuring a complete history of all interactions. Let's take a look at how the process flow works. First, we have the creation of a relationship, meaning the provider creates a PPR contract when they start managing data for a patient. And the PPR contract is linked to the patient's summary contract, which aggregates all the relationships. Then we have the granting of permissions. It is the patient who approves or modifies the access permissions, and they do this through the PPR, a contract that essentially regulates who can access the data and to what extent. Then we have data access. Now, when a user requests access to the data, it is the PPR contract that checks the access permission and provides the instructions to access the data in the provider's database. Finally, updates. When a new record is created or an existing one is modified, it is the PPR contract that automatically notifies the patient of these changes. The patient-provider relationship contract is the operational core of MedRec because it manages the relationships between patients and providers, ensuring that data is accessible only to those who have received authorization with complete traceability of all interactions. In this way, with this decentralized approach, both the security and control of the data are improved. And moreover, it facilitates the relationship and collaboration between patients, doctors, and potentially researchers. Let's move on to the summary contract, which is designed to provide an aggregated record of a participant's relationships, whether provider or patient, with the other actors in the system. And so it acts as a personal index that allows users to quickly access their medical history and related access permissions. So, the functions of the summary contract are, first of all, as mentioned, to serve as an aggregated record of relationships. Because the summary contract contains references to all the PPR contracts associated with a user. For a patient, it represents a complete record of all the providers they have interacted with. For a provider, on the other hand, it represents a complete record of the patients they have served or with whom they have an active relationship. It also serves as a centralized access point because it allows each participant to view all their interactions and authorizations, all in one place, simplifying data management. So, traceability of changes, because every modification to associated contracts, for example, the creation of a new record or the modification of permissions, is recorded and can be tracked through the summary contract. Finally, notification management, meaning the automatic alerting of the user about any changes and updates, such as the creation of a new contract or the modification or update of a record. In the structure of the summary contract, there is a list of PPR contracts because the summary contract stores pointers to all the PPR contracts associated with the user. And each entry in the list includes information such as the address of the PPR contract and the status of the relationship, that is, whether the relationship is active, has ended, or is pending approval. Finally, there are relevant metadata such as the timestamp and the hash for integrity verification. Let's look at a practical example, which is always the best approach. So a patient wants to know which providers have access to their medical data. What do? They check the summary contract where all the PPR contracts are listed, and they look in detail, viewing the relationships and the permissions granted. Another illustrative example, a healthcare provider electronically fills out or meticulously updates an individual's medical record. The patient's comprehensive summary contract is automatically and instantaneously updated and sends a clear and concise notification directly to the patient about the significant change that was just made. Another essential operational component of MedRec is the system node, which is used to facilitate interaction between the blockchain and the local databases of the participants. That is the system, so providers, patients, or possibly researchers. In fact, the system node is made up of 4 main components, which we'll quickly go over. We have the backend library, the Ethereum Client, the database Gatekeeper, and the EMR Manager. The backend library is the brain of the communication. Think of it as having a personal assistant who manages all communications between MedRec and the blockchain. It's a set of tools that simplifies interaction with the blockchain, builds transactions, and sends them to the Ethereum client for processing. It automatically verifies that every operation on the blockchain is confirmed, ensuring that the data is always up to date. So can we define the backend library? It's a sort of intelligent translator for MedRec that manages and simplifies communication with the blockchain without the need for manual intervention. The Ethereum client is the node that keeps everything connected. If MedRec were a highway, the Ethereum client would be the traffic control network. In fact, it keeps the system node synchronized with the blockchain, handles validating transactions and recording them on the blockchain, and then executes the smart contract. So, in fact, the Ethereum client is the connection engine between MedRec and the blockchain, ensuring that all operations are validated and recorded securely and up to date. The Gatekeeper database is the guardian of the data. Medical data is sensitive and therefore must be protected. This is the reason for the existence of the Gatekeeper database, which works as a guardian, a sort of digital gatekeeper that controls every access to the data stored on local databases. When someone requests information, the Gatekeeper database checks the permissions in the PPR contract on the blockchain, ensuring access only to those who are authorized. If everything is in order, the Gatekeeper database retrieves the data and provides it only to those who are authorized. So it's the Gatekeeper database that is responsible for the security and privacy of data in MedRec, allowing only authorized access. The EMR Manager is the interface between patients and doctors. It's the application that allows patients and providers to view, manage, and share medical records. It shows real-time updates and sends notifications when there is new information, thank you, or access requests. Additionally, it facilitates permission management, giving patients control over who can see their data. So in fact, the EMR Manager is what determines the so-called usability of MedRec, meaning how easy it is to use. What did you think of MedRec? Easy? Difficult? In my opinion, it takes a little while before you can fully understand its functions. What I like to point out is that, first of all, it's a project based on a public blockchain. Permissions like those on Ethereum, in my view, are sufficiently accessible to understand. And it's a good example of a project that uses blockchain technology for managing healthcare data. In the video description, as usual, you'll find the bibliography, and in the bibliography there's a link to the paper. Basically, we can consider it a sort of white paper, and when you read it, if you feel like it, there are two figures. Figure 1 basically graphically summarizes the functions of the three smart contracts, the MedRecs, namely the register contract, the PPR contract, and the summary contract. Whereas Figure 2 is a graphical example of what happens when an external provider enters a new medical record for a new patient. It shows the various interactions between the MedRec smart contracts and the components of the system node. Maybe, with what I've explained to you, you should be able, by following the figure, to put everything together and understand how it works in the best possible way. There's another thing I like to talk about regarding MedRec. It's the reason I chose MedRec as an example. And that's MedRec's mining and incentive system, which is basically based on what are called bounty queries. In other words, we can define them as reward requests. MedRec uses the Ethereum blockchain. Therefore, transaction validation takes place through the consensus mechanism. This is typical of this blockchain, which used to be proof of work and is now proof of stake. However, MedRec also introduces a mining model that is specific to its own ecosystem, designed to incentivize key participants in the healthcare sector, such as research organizations or healthcare institutions. And it is no longer based on the reward of a cryptographic token, as happens in traditional mining, but rather on access to health data in anonymous and aggregated form, which can be used for studies. Let's take a look with a diagram at how this rewarding mechanism based on so-called bounty queries works. Let's see how this rewarding mechanism works. At the first step, we have transaction filtering, meaning the MedRec miners monitor the Ethereum blockchain looking for transactions directed to the MedRec smart contracts. In this way, they essentially filter them out from the other transactions on this blockchain. At step 2, when the healthcare provider updates a PPR contract, for example, by entering data, they are required to do so. To attach a bounty query to the transaction and the bounty query, it is a data request. Then, at step 3, the MedRec transaction is inside a block, meaning each transaction. MedRec with a bounty query is included in an Ethereum block. At step 4, there is validation, meaning the miner who validates that block automatically becomes the owner of all the bounty queries associated with the MedRec transaction present in that block. This mechanism is managed by the special function of the PPR, a contract that assigns the miner as the owner of the bounty query when the transaction is recorded on the blockchain. So at that point, which is step 5, after validating the block, the miner can execute the query by contacting the provider's Gatekeeper database. Finally, the provider's Gatekeeper database checks the permissions and delivers only anonymized and aggregated health data that can be used for research. MedRec can be considered a prototype. That is, it never reached a commercialization phase, at least according to the information I was able to find, and it remained active between 2018 and 2019. In any case, in my opinion, it serves as a good example, a good training ground, not only to understand the complexity of the topic, but also to grasp the dynamics necessary for applying blockchain technology to the management of health data. We've reached the end of this video as well. A tough, complex video, and also quite long. After all, these are rather complex topics, and you need to invest some time to get to the bottom of them. If you've stayed with me until now, I thank you. And if you enjoyed what you watched and listened to, give it a like. From now on, I'll be alternating videos dedicated to startups or projects like MedRec, which focus on the use of blockchain in healthcare data management, with videos that are more general, more conversational. So if you're interested in these kinds of topics, subscribe to the Blockchain 4 Hack channel and see you next time.